Okay, hello there, BC Calculus students. It's time to look at our scoring video here for the last three problems of 2014. And take a look at these, and this will be our last assignment for the week. So, here's question number 4. We've got trains, and we've got a chart here. Notice that our table gives us velocities in terms of time. So let's see what we need to have here. So first, for part A, it's just 1 point, knowing its average acceleration, which is the average rate of change of the velocity. So we need to see our difference equation here, our difference, I should say, ratio. So we need to see the ratio of the differences. We can leave it like this, or we can simplify. And I believe we do have to have the units. No, we don't. So the units are not necessarily required to get the 1 point for part A. For part B, basically what we have here is we have 1 point for establishing that the velocity of train A at 8 is less than negative 100, which is less than the velocity of train at time 5. Therefore, that means that there must be a time between 8 and 5 where the velocity of train A is negative 100. And you have to reference the intermediate value theorem or state everything. And you need to include that it's continuous and differentiable, and you need to use the IVT there when you're doing that. So, if you didn't say continuous and differentiable, you don't get your IVT point. If you don't reference the IVT, you don't get that point either. Okay, part C. So part C, you need an expression for the position. That's found right here. The position expression, so what you need to have is you need to have an initial value plus the integral going from 2 to 12 of the velocity function dt. So it could be this right here, or it could be this right here. You could just simply insert the 300 to get your position equation. Then you must have your trapezoidal sum, which is listed right here. It must be a sum written out like this, where you can see it's trapezoid. So you've got to have you got to see that the two bases are added together. You've got to have the multiplication. You can easily have times a half instead of divided by 2. That's fine. And then if you actually get the correct position, which is the negative 150, you get your point there. You must have a sum here, which means you're adding together these trapezoidal areas. If you just have this, that won't do it. You got to see the sum. Okay, so part D is worth 3 points. So first, here's your implicit differentiation. So you need to see the implicit differentiation in order to get, and that's worth 2 points. And then simply being able to substitute in and get it down to the 160 meters per minute, that gets you your third point. So 2 points for the correct implicit differentiation, and then an additional point for your answer. Okay, score that out of 9, and let's move on to question 5. So question 5, we've got, question 5 is the one that's going to be part AB and part BC. So we see here, first off, for part A, we want to find the area of this region that we have defined here. So as we look at this, probably the easiest way to think of this is you're actually finding the, you have the area of the region above the x-axis and below the x-axis. So your expression would work here. Now, you can treat this here as just a triangle and go ahead and get the area of that triangle, and you can do it that way if you want to, is get that area in that form, but you don't have to, but you can do it that way. It certainly is just as adequate if you find the area there, and you just go and add that to the area that you would find there. To get that one, though, you have to go 0 to 1. So you have to go x, integrate x e to the x squared. your correct integrand there. You don't have to have the minus, the negative 2x, if you've got it either you have to have it as a separate integral, or if you just calculate the area of that triangle, that also will work as well. Either way's fine there. And then when you go and you do need to do your correct antiderivative, if you do have this in your integrand, then you do need to antidifferentiate correctly. So you get that expression right there. And then if you actually get your answer, which can be left in this form here or written in that form there, either way that would be either way that's going to be fine when you do it like that. Either way you'll be okay. All right. So for the next part, for part B, for the volume, you get 2 points for your integrand. That is realizing that you must do these separately because this one's negative here. If you're so you're going to integrate, this is your base squared. Sorry, I should say this is your radius squared. And the pi can be inside or it can be outside. And this is your radius of the other region squared. And so you integrate from 0 to 1. The correct integrand here, if you get one of these but not both, you get 1 point. Having both inside, whatever's inside the parentheses, it can include the pi, so long as the pi is not inside what is squared. And then if you have the correct limits, you got your pi, and then you got your 0 to 1, you get your third point. Finally, for C, this is the BC part of it. So you do have to you have to know your formula for the length of a curve. So if you look at this here, the perimeter, you can find, if we look at this here, you can find this side by using Pythagorean theorem. You can find this side simply by evaluating what this y value is and adding that value in there. So you can see that that's where you get the radical 5 using Pythagorean theorem. You get the 2, and then the e are those two pieces together there. And then you have to integrate to get the curve. You have to use your length of the curve formula here. So you get 1 point if you know to take the derivative of the function, and you do it correctly. So if you get that for the derivative, you get 1 point. If you have the correct integral, that's this part here that you know you must integrate from 0 to 1, and you know to take the square root of 1 plus your derivative squared. That whole correct integral gets you the second point, and if you correctly added it to the other pieces, you get your third point. Okay, score that out of 9, and we'll move on to one that is definitely BC. It is our series question. So let's go ahead, let's take a look at what we've got here, how to score this one. So first, if you set up the ratio, here is our ratio. Now remember, you can write it as the numerator times the reciprocal of the denominator, or you can write it actually as a fraction. But if you set up that ratio, then you get 1 point, even if you don't find the limit. If you compute the limit of the ratio, even if you compute it wrong, you get a second point if you actually compute a limit. Now, if you compute the limit correctly and get the correct radius, you get the third point. For part B is worth 3 points. So you get 2 points for the first 3 non-zero terms. My best guess here is they will give you 1 point if you get the first 2 terms, and then a second point if you get all 3 terms. And then you get 1 point for an expression of the general term. It can be written with a series notation, that is fine, or you can just simply write the general expression. And then for C, it's also worth 3 points. So you get 1 point if you take the correct derivative and get this value right here. So that's 1 point if you do the correct derivative. You get 1 point if you do the correct antiderivative of that, which is going to be this. So another point there for the correct antiderivative. And then if you actually then go and find the function, which is going to be this natural log of the absolute value of the 2x minus 1, finding the function there for f of x that gets you your, that means you have to solve for the C. That's the key thing, is find the C is 0 and get that expression. Then you get your third point. Okay, score that out of 9, score the whole thing out of 27, take a picture, and then go ahead and turn it in. And I hope you guys have a good weekend.